Okay, guys, we're going to whip through the last section, the last new section, I guess, of Unit 3. So we're flying through this course. Unit 3 is almost done. Let me straighten this out a little bit here. Unit 3 is almost done, and the last part of it is going to be section 3.5 in the textbook. So once again, we're kind of jumping around in the textbook, but it's the last part of probability is looking at combinations of probability. So combinations order doesn't matter. Okay, so that is what I'd write there. So order doesn't matter. So things like this, it's not this question. It's not you know, you're choosing. You have 5 friends and you want 3 of them to line up in order. That's not the question. The question is you have 5 friends and you want 3 of them, and all you do is this: 5 choose 3, 5C3. And that's 5 factorial over, we had this before with the P, is that it's 5 subtract 3 is 2, but you also have to kind of get rid of the redundancy, or the, sorry, you kind of have to add in the redundancy and get rid of the uniqueness of things. So for example, if you have friends A, B, and C, who choosing those 3 in that order is the same as choosing them in this order or any other order that works, B, A, and C, okay, because you're just choosing the friends. The order that you chose them doesn't matter. Okay, so that's combinations. So that's how that works. And again, for probability, what you're looking at is this. You want the number of ways something, you're looking for success over total. Okay, so again, success over total. So the number of ways that A can happen over the total number of outcomes that you see. So success is on top, total number of ways on the bottom. And as you noticed with the last unit, this can be a little bit hard, a little difficult, a little long. So I'm just going to jump around, do some questions. I might skip 1 or 2, but these questions seem similar to the ones from the last unit, and from the last day. And I did that on purpose just to show the slight differences between them. But even though the wording is slightly different, the way you approach them is the same. But then when you count, you need to use combinatorics instead of permutations. Okay, so we go through this here. I want 3 people out of a group of 11. How many ways can we make this committee? And this is just this: 11 people. You choose 3, so that's 11 factorial over 3 factorial and 8 factorial. Okay, you want to write this 8 factorial first, and then 3. You can do that. Okay, and that's a number, and that's going to be your denominator in this question. So just like before, you have to figure out the denominator and the numerator. Total number of ways is on the bottom. The question is, how many ways can we have Jesse in the committee? What is the probability that Jesse is in the committee or on the committee? So what you think about this: if Jesse is already on the committee, how many ways can I choose these next 2 people? Well, if Jesse's gone, I'm down to 10 people, and I'm choosing 2. So it's 10 choose 2. So this answer is 10 choose 2 over 11 choose 3. You figure out that number. That's a number. That's a number, and then you put them in the calculator, and you get a decimal. Okay, and that's great. You keep going. How many different ways can you make a pizza? Again, pizza toppings, when you look at toppings, order does not matter. You have a ham, bacon, and tomato. It's the same as tomato, bacon, and ham, or whatever. Okay, so there you go. That's how you choose the number of toppings, which ironically is the same as that. And from there, okay, so I got a little interrupted, but anyway, 11 toppings, you choose 3. So again, that's the same. Coincidence, it's the same as above. And then what you want to do is figure out the probability that you don't like your meal if you don't like anchovies and olives. So you don't like anchovies and olives. We're going to say anchovies. We can do this 2 ways. We can say we don't like them together, or we can say we don't like them at all. Okay. So one way to do this is to figure out how many pizzas have anchovies and olives. Another way is to figure out, sometimes you go backwards and figure out how many don't have anchovies and olives, but let's do this one here and say how many pizzas have anchovies and olives. And that's really easy, because if you are choosing those 2, that means that you only have 1 choice left, and that is of 9 things. So it's just 9C1, which is 9. Okay, but so that would be the top. Okay, so you're choosing the number of pizzas with anchovies and olives in them. And then on the bottom, you have the total here. And then you figure that out as a fraction, and then you move on. If you were to say anchovies or olives, what you would do is you would figure out how many pizzas have anchovies in them and how many have olives in them. You want to be careful that you don't double count anchovies and olives. So what you would want to do probably is anchovies. How many pizzas have anchovies and not olives? How many pizzas have olives and not anchovies? That would be the same number. And then how many pizzas have both? Okay, because you don't want to double count. So you could do that, but this is the question I meant to ask. Okay, next up, how many different combinations are possible if 2 regular dice are rolled? So 6 times 6, it's 36. We've done that grid a bunch of times. And then what's the probability of rolling at doubles or at 8? So just be careful on this, because what's going to happen is this. When you figure out the number of ways to roll an 8, you go 6 and 2, 5 and 3, 4 and 4, 3 and 5, and 2 and 6. And I didn't miss any, I don't think. So there are 5 ways to roll an 8. That's right. And then you get 1 and 1 is a double, 2 and 2 is a double, 3 and 3 is a double, 4 and 4 and a double, 5 and 5 is a double, 6 and 6 is a double. And then you say there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But the problem is you double counted this. Be careful. Okay, 4 is twice. So it would just be 10 over 36. How many ways can you make a word from this? So 1, 2, 3, 4, 5, 6. 6 letters lined up, and divide by the number of repeated letters, repetition. So you see the D's twice, so you divide by 2. So that's a number. And what's the probability that the D's are together? So this guy, if you can believe it, a fraction, whatever number that is, don't leave it as a fraction. That's your denominator. And then on the top, you want to figure out how many words you can form where the D's are together. And what you're going to do here is treat the D's. So this is like when the 2 guys sit together. I think that was in yesterday's question. But the difference is these D's are identical. Okay, so when you go A, B, C, D, and you say, let's put the D's together. Now, normally, when I said, let's line up our friends Bill and Mike together, they have to sit together, you would say, well, it can go Bill, Mike, or Mike, Bill. Okay. But in this case, if I say it goes DD or DD, it's the same thing. So you're not going to multiply this by 2 factorial. Okay. Instead, you just put them together, you group them together. There's only one way to put them together. So you have 1, 2, 3, this giant letter 4 and 5. So now it's 5 factorial ways to line those guys up. So the number of ways you can line up the letters where D and D are together is 5 factorial. Okay, and then the bottom is 6 factorial over 2 factorial. And all of these are going to be very similar. What you're going to do is, what is the probability that you draw a hand of 5 cards that contains blank? And all of the denominators, every single one is going to be 52. I was right the first time. 52, choose 5. Okay, so all your denominators is this big number here, and then we're just finding the numerator. So this is really easy. I mean, I've asked you these questions a bunch of times before. 3 aces. If you're choosing 3 aces, you're choosing 3 of the 4 aces, and then at that point you take the aces out, and you have 48 cards to choose from, and you're going to choose 2. So that's your numerator. Divide by that. At least 3 aces. So you're going to have this situation, and then you're going to add the situation where you choose 4 aces. And that's this situation. Okay, so you choose 4 out of 4 aces, and then you choose 1 of 48. So you add these 2 together. That's a bracket, not a C. And you add those together, and then divide by that. The 5 of clubs, if you choose the 5 of clubs, you chose the 5 of clubs. There's only one 5 of clubs to choose from. And that means of the other 51 cards, you're choosing 4. So that's your numerator there. All red cards. So 2 ways to look at this. One is to say no black cards, but it's the same thing if you do or not. So you can say I choose no black cards, and I choose 5 red cards. Okay, but you know this here is going to be 1, so you don't really need to have that. 26, choose 5 over this. No face cards, so this is a little different way to do this. No face cards. There are 4, 8, 12 face cards, so there are 40 non-face cards, and you're choosing 5. A full house, little time to think about this. A full house is going to be a pair and 3 of a kind. We'll do this in class. This will take a while. Okay, kind of interesting. If you're doing this, If you're doing this, what you have to do is choose. The first thing you have to do is figure out who's going to be your 3 of a kind, what's going to be your pair, and then after that, then you choose from your cards. Okay, so there are 13. Oh, let's do this. Okay, so full house is 3 of something and 2 of something else. Okay, and it's like 3 kings. 3 kings, king, whatever they are, and 2 jacks. Okay, but what you're first going to do is you're going to figure out what these guys are, who's your kings, and like who's your 3 of a kind, and who's your 2 of a kind. So what you'll do is from the 13 different numbers. Okay, so that's from ace all the way to king. There are 13 different cards, right? Ace, 2, 3, 4, all the way to king. You're going to choose from them. First, you're going to choose your 3 of a kind, and then from the 12 remaining, you're going to choose your pair. So you have to say, who's my 3 of a kind, who's my pair, and this is 13 times 12. Okay, you also could have just done that 13 times 12. You also could have said, choose 13, choose 2 of them, and then line them up. Okay, but either way, it's 13 times 12. And then what you have to do is figure out, okay, now I've chosen, let's say my kings and my jacks, which go with that as my example. So from the kings, you need to choose 3 of them, and from the jacks, you need to choose 2 of them. Okay, and that's all 5 cards. There's no other cards left over. Kind of a neat question. Okay, you multiply all that out, and that is your numerator, and then denominator is what we had earlier. What's the probability that there is at least 1 male in a committee if the committee contains 3 people? So a lot of these at least 1 males and stuff like this, you're going to be adding things together, but sometimes it's easier to figure out. It's easier to figure out the situation where this does not exist and subtract from the amount. So let's go over this. So what's the probability that there's at least 1 male in a committee if the committee contains 3 people and there are 11 males and 20 females? So what you can do is go through this and say there's 1 male, at least 1 male means 1 male, 2 males, or 3 males. You can do that. There's no problem. But it might be easier to say, look, there are a total number of committees, right? So if you look at this whole thing here, let's figure out the total number of committees. There are, can you see that? If I just said, I don't care about, no, there's not 30, there's 31. There's 31 people, and what I can do is choose any 3 people from there. Okay, so that'd be the total number of committees, just randomly chosen without sex mattering. And then what you could do is say, subtract from that the number where we're only females. Okay, and if you did that, you could go through there and say, there are 20 females, and I'm going to choose 3 of them. Okay, so this is only females because I have no males. Okay, and you could figure out that number here. That would be your numerator. Your denominator is just going to be this itself. So 31, choose 3, which is the total ways of choosing 3 people from a committee. Okay, so a bit of a tricky question. What's the probability that a garage door opener? Okay, remember garage door opener codes? They're up and down. You have switches that are up and down. So you have up, up, and we treat this like a word, right? Up, 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 down, down, etc. Using these. Contain the same amount of up and downs. Okay, that's a great question. And what you're going to do, what that means, what's that mean? Think about that for a second. If we have the same amount and there's 8 total, that means that we want the number of words that contain U, D, 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 4 of each. Okay, and that is going to be 8 factorial over 4 factorial, 4 factorial. That's the number of words that you can make out of that. And the total number of words that you can make when you have U's and D's is, remember, it's a little different. Okay, it's a yes/no type question. For this question, is up or down. That's 2 options: U or D, U or D, U or D, and the answer is 2 to the 8. Remember that? Okay. So it's yes or no. So it's off, off, on, up, down, that sort of thing. So I have 2 options for the first question, U or D. For the first switch, sorry, up or down, up or down, up or down, all the way down. And it's 8 of them, so it's 2 to the 8. So that's your denominator. And then we're going to figure out how much money, what effort you should make into trying to win the lottery.